Welcome to Get Your FRQ On. This question is from 2003. It's question 1, and it is calculator active. In the question stem, we are provided two functions, y equals the square root of x and y equals e to the negative 3x. And we are given the graph of the region bounded between those two curves and the vertical line x equals 1, and this region is given the name R. In part A of the question, we are asked to find the area of the region R. Right, well, in order to find the area of the region R, we have to know what the bounds of integration are. The upper bound would just be x equals 1. The lower bound is wherever these two functions intersect. Well, this is a calculator active question, so I can use my calculator to determine where these 2 points intersect. Right, so the 2 points, by using my calculator, intersect at the point A comma B, which has coordinates 0.2387 and 0.4886. Right, so the area of R, I'm going to have to find by using a definite integral where my lower bound is this value of A, 0.2387. Right, so the area of that region is the integral from A to 1 of, and I also have to know which of these functions is on top of the other one, which one is the one that's further away from the x-axis. Turns out that is the square root of x. That's why the square root of x is written first here. So we have the integral from a to 1 of the square root of x minus e to the minus 3x dx. This is a calculator active question. Use your calculator to do this calculus. There's no point in trying to do this by hand. Get the decimal, be done, get it over with. You don't get extra points for having shown all the work by hand if it's a calculator active question. Sorry, it's just not going to happen. So the integral, that area of R is 0.443. In part B of the question, we are asked to find the volume of R when R is revolved around the line y equals 1. Now, since we're revolving around the horizontal line y equals 1, the outer radius of this solid will be determined by the function which is closer to the x-axis, which means it's going to be further from the line y equals 1. All right, now normally you might have to justify this. This is just sort of an editorial statement. They provide the graph of the region R. If you know which one is which, it's clear. Y equals e to the negative 3x is the one closer to the x-axis, so that will be my outer radius, 1 minus that function, and my inner radius will be 1 minus the square root of x. So if I'm going to revolve this thing around the line y equals 1, we have pi times the integral from a to 1, and since I defined what capital A represented, I don't have to keep reusing the decimal over and over. I can just use the symbol A. And then I have my big radius, 1 minus e to the negative 3x squared, minus my small radius squared, or 1 minus the square root of x squared dx. Again, calculator active question. There is no point trying to do this by hand. Let your calculator do the work. At this point, we have already clearly communicated to the reader what it is we are asking our calculator to do. We have satisfied whatever the requirement is to get the points for having the integral set up. The only thing left for us to do is to get the answer, which turns out to be 1.424. In part C of this question, we are asked to find the volume of the solid when cross sections taken perpendicular to the x-axis are rectangles where the height is 5 times the base, and the base would just be the difference between those two function values at whatever value of x we are at that time. Right, so the area of the rectangle, right, at any given value of c, right, its base is one thing, and then its height is 5 times that base. So that value would be a function a of x equals 5 times the difference between those values squared, because I have 5 times that difference is the height, and then that difference is also the base. So I have two factors of square root of x minus e to the negative 3x squared. Right, so that is my area function. That tells me the area of one of these rectangles anywhere in that interval. All right, so the volume of this solid can be obtained simply by integrating my area function a of x between a and 1. right? Now notice I didn't use capital A here in the bottom because I'm using A up here for my area function. In order to remove any ambiguity, it's probably safer to use the decimal here. So the volume is the integral from 0 to 0.2387 to 1 of this area function dx. And again, it's a calculator active question. There is no point in trying to do this by hand. Use your calculator to find this volume. The volume is 1.554.